this is our case study, or at least half of the case study, because obviously I wanted to find an interesting company to be simulated, but also this simulated company had to have a simple or easy to model product. So I could focus on an ice cream factory, but that would be boring. So rockets obviously is the choice. And in this case, we can see an industry which is emerging during the last 10 years at least. So we can see a lot of not just startups, but now close to mature companies, close to mature products everywhere in the US, in Europe, in China, in India, or even in Australia as well, which are collecting a lot of investors from venture capital funds. Some of them were listed on the stock market, some of them already defaulted, some of them are growing, some of them is still before testing. Some of the people were coming from the automotive sector, so we can see a lot of movements, and that's why we have a lot of data. But what can we see here? So what determines the fundamental value for a commercial orbital launch service provider? So obviously, this is how the business looks like. This is our planet Earth, and this is when we are launching this happy satellite to orbit. And one key component of the rocket, obviously, first stage will just go up until 80 kilometers, then release the second stage on the satellite, and then fall back into the ocean. And yeah, we lost this asset. Then the second stage will still ignite its engine and pushes the satellite up to orbit, or at least close to it. Doesn't matter. We are not engineers, we are economists. And then after that, they are releasing it, and then we get the money. Obviously, the second stage should be reignited and then let it fall back to the Earth and to burn up, but it doesn't matter. It's a technical issue, not an economic one. So this is what we can deliver easily. This is what we can call commercial orbital market nowadays, because the rest of the orbits or geostationary orbit, this is where satellites are always pointing at the same part of the Earth. So when we are thinking about meteorological satellite or satellite TV or things like this, they are really heavy. So we are talking about tons, and they are really expensive, and there is not much market for them. So where the money is during the last 10 years is low Earth orbit, because in this case we just have to launch up stuff for 300 kilometers until 2,000 kilometers. Obviously at the 300 kilometers we are really, so Earth's atmosphere is still around there. So we have still atomic oxygen and other atomic things. So it slows down satellites eventually, so there is atmospheric drag at that part. So you need to ignite engines to compensate this, but also this is where the money is. Why? No, so before going on, so I don't care about Moon, I don't care about Mars, Venus, Ceres. These are nice parts as well, but not on commercial basis. So we can get some money from ESA or other space agencies, but maybe once in a year or twice in a year. So we can't build a company on this one. Okay, next thing. In the past, satellites were heavy, as I mentioned. So it was about tonnage, 5 ton and 4 ton. And also they were not standardized at all. Nowadays, many companies are using off-the-shelf products. So what is in the laptop, in the computer, because now they are reliable enough. Maybe they are just putting 3 computers in a row, and if they are hit by cosmic radiation, then they are just excluding the misfiring chips. But that's why they were able to cut down the weight. So nowadays a satellite is much more like some hundred of kilograms. So there was a significant weight reduction. Also, you can buy or order satellite buses, which means that The satellite bus means that you can get all the electricity, propulsion, communication. So it's integrated, and after that you just have to build or integrate your cameras, sensors, dishes, or whatever you need on the top of this. So this kind of modularization is absolutely present in this industry, which means that satellites became way cheaper than before, which means that we have a much bigger market as well, because nowadays many companies are manufacturing, and also many companies would like to build up their own satellite business. So in low Earth orbit we have weather, imaging, but what is really important, communication satellites, Internet of Things, phone. Nowadays the big thing, current thing is that satellite to phone or cell to satellite communication, that in the US and also some parts of Europe, already Apple provides the service that you can send without any modification. So with just retail phones. Okay, not this one because this is Xiaomi, but with iPhones, you can send text messages through satellite. Which is really good because sooner or later it will open up further applications. If you are in the middle of nowhere and if you are in trouble, it's way better. Or otherwise, you can buy Iridium satellite phones for a huge amount of money and you can do the same thing. So, Internet, I will talk about it later. So, for example, Internet of Things, to understand the scale, that nowadays real-time diagnostics are really important. So in the past, when you had a fleet of locomotives in the railway logistics, then after a specific amount of mileage or operational hours, you had to send the locomotive for a weekly check, or once you were reaching a mileage, then the locomotive had to be taken apart to check the brakes, engine, and so on, then put together, and until it was just staying there and not generating revenues. And maybe the components were close to breaking, or maybe not. So right now, Deutsche Bahn, for example, or DB Cargo is equipping all their vehicles, their entire fleet, with sensors. But in this case, you can see that is the vehicle close to breaking or not? Because if it's not, then you should send it back to work. You don't have to stop it for inspection and other things. So this sensor integration is a really important thing right now in the logistics sector, but also the same thing is for shipping. When the airplane was disappearing, it was Air Malaysia something, you know that they were able to get the location because the engine was still transmitting data for the manufacturer, diagnostic data. So this is the same thing. And in this case, you can pick up this signal only by satellites, because otherwise you don't have cell towers everywhere on the planet. So IoT seems industrial, but sometimes it's way more profitable than business-to-customer relationships. So, as I mentioned, internet, satellite internet is the big business. In the past, it was completely the monopoly of Iridium Communications. They started this job in the 90s. I think they told it only once since then. At the beginning, they were just building up poor internet coverage, but they were in monopoly. So after in 2017, they refurbished, so they started to launch new satellites to provide high bandwidth. But the problem is that in this case, they have only 66 satellites, but they are far from Earth. So they are providing a nice bandwidth, so it's real internet. But since they are far away, then the lag is also really high, because the data should travel far away, then come back. So we are talking about hundreds of kilometers. And also we can see that, yeah, this kilobit is good enough. But they had this monopoly, and also they have a nice customer base with 2.3 million subscribers. We have another beautiful British company, or now it's merged with Eutelsat, OneWeb, which defaulted also 5 years ago, or now 6 years ago. Now they have 670 operational satellites. So this is not a business plan, this is operational business. But in this case, they are focusing only on businesses. So they are only making contracts not with customers, but their customers are telecommunication companies. As we can see, they have way more satellites, which means that they can closer to the Earth's surface. Obviously, that's why you need more, because they should move faster to avoid falling into the atmosphere. And that's why they have lower latency, so lag is lower, and also bandwidth can be way higher. So now we are talking about megabits, so this is real internet. But obviously, the elephant in the room is Starlink. So Elon Musk, when it was announced, everybody was saying that, yeah, the Musk thing, again, like self-driving cars. But after that, they built up this monstrosity of 7,551 operational satellites, and it's always growing because they're launching once or twice a week, 60 satellites into orbit. Okay, some of them are falling back, but yeah, we can see that it is a bit higher in terms of scaling. So we are talking about thousands. And also in this September, they were reaching 7 million subscribers, and the whole thing became profitable already during last year. So they were able to expand exponentially in terms of customers. And since they are manufacturing completely in-house, I can't say completely standardized, because some of their satellites have now direct laser connections. So, because the problem is in many cases that if you are using the internet, satellite internet, you have to send out the data, then the satellite is only operating as a relay, because after that they have to downlink it to some ground station, and after that you are connecting to the internet. In case of Starlink, since some of the satellites are already connected to laser data, so practically this is fiber optics, just without the fiber, because you don't need in space, because it's vacuum already, or close to vacuum. So it means that practically they can build up a parallel internet. A cloud, it's not cloud because in vacuum, so cloud in vacuum. And in this case, they don't have to maintain much of the downlink capacities, which can create faster connection speed, because right now you have to downlink it, you have to go to the next server or data center, then after that it can be transferred. So you have to go through a lot of joins, and in this case you can bypass it if you have enough satellites. And now they have enough satellites. So already 2 years ago they started to test, and now they are providing direct to cell satellite-to-satellite connections. In the US they have T-Mobile, which is providing their services, and also sometimes, or some places in Europe, already we have a similar business, not in Hungary, but elsewhere. So we can see that obviously these satellites must be launched somehow. And still we have one player which is missing. This is Amazon. So obviously Amazon, which is big in online sales and as a shop and store, but majority of their profit is coming from their data centers. So they, I can't say they invented the cloud, but they contributed a lot to the cloud services, and obviously they want a piece of this cake as well. So Amazon, or at least Jeff Bezos, created a secondary company, Blue Origin, and Blue Origin is developing their own orbital class rockets. They launched it this year. It was the first maiden launch. Usually they are exploding. Until the fourth launch, we can see nice explosions in many cases. But after that, they would like to build up their own satellite internet, because obviously they are interested in the cloud services, so they would like to participate in this thing as well. There are some people who are saying that, yeah, but we will see servers in the low Earth orbit as well. The problem is that you don't want to put servers there, not because of radiation, it's not the biggest problem. The problem is that you cannot get, it's really hard to get rid of the heat in space, because there is no atmosphere, so you can get only radiative cooling. So you need huge radiators, and then photons will dissipate off the heat. So for a data center, which should be already cooled by water nowadays, and really specialized AC systems, I don't know. So we need some kind of a revolution in the chip manufacturing. We'll break some laws in nature, but until then we don't have profitable satellite or satellite-based data centers. Yeah, so what determines the profitability and the value? Of course, we can see the problems here. So first of all, launch cadence. How many times can we launch in a year? So if we are Arianespace, which launches the Ariane 6 maybe 3 times, 4 times in a year, this is laughing stock. So it's in this case, you have to maintain all the manufacturing lines, you have to maintain all your workers and launch towers, testing facilities. So you have to maintain all these things here around expenditure. So you have to manufacture engines. So right now we have absolutely no modularity. Everybody is developing their own engines. Everybody is developing their own tanks for oxidizer, or oxygen usually, and something which you can burn up. So it can be methane, it can be kerosene, it can be hydrogen, or it can be some nasty other, what is the name of this? No. There is the cryogenic fuel, and there is the other one, which is when you are just putting two things together and instantaneously they are burning. But they are absolutely toxic in the other ways. Okay, hypergolic fuels. You can store them in room temperature, just you don't want to eat them or to be near them at all. So tank manufacturing is there, vehicle integration, all the wiring, testing, software, launch equipment, fueling infrastructure. This is absolutely atomized nowadays. So this is what we would like to avoid in our case study, that we are saying that, okay, let's buy an engine from here. Okay, we are manufacturing tanks in-house. Northrop Grumman was Orbital, then Orbital ATK, then they were acquired by Northrop Grumman, is trying to do this for many years now. So they were buying engines from a Ukrainian manufacturer, but it was coming from the Soviet moon program. Then at the fourth launch, it was exploding on pad, so they moved to a Russian manufacturer, but the tanks were manufactured by a Ukrainian company, and at the end of the day, they were just building things together. So this is how they were trying to fulfill their NASA contracts, and they were more expensive than SpaceX. So, yeah, it was a profitable business. So we can see that it can be. We need a lot of assets, really expensive assets. So we need a lot of 3D printers, lots of CNC machines, but many of them can just come from automotive sector. Some people, like Rocket Factory Augsburg in Germany, they are saying that you can even use parts from the automotive industry, because you don't need age-rated things anymore. So if the standards are good enough for cars, to manufacture cars, which has high mileage, which has really good precision manufacturing, then it's good for you as well. Or also in engine manufacturing, you don't have to bolt things together. Nowadays, you can 3D print many parts which were manufactured from small components like injector heads. So in many cases, companies, startup companies, so not legacy defense companies, are saying that, okay, we are just buying raw materials, sheet metal, titanium powder, and so on. And after that, with the standard industrial equipment which can be used to manufacture cars, we can manufacture rockets. So this is where we are right now. Okay, so rocket kinematics for economists. 101. So we have some components here that we should remember. First, we need an engine. So this is the flamey end of the rocket, so obviously it has been rotated by 90 degrees, but this is where the flame is coming from, so obviously we need engines. Usually more than one, because in this case it's cheaper to manufacture and also more reliable, because if one is not functioning, then still the rest can carry the cargo. Some people are saying that solid rocket boosters are good because in this case you can scale up the cargo. So if you don't need all the cargo capacity, you just should not put solid rocket boosters next to it. The problem is that we cannot recover this one. So we are spending $3 million for each solid rocket booster, and after that we cannot recover that one. So this is useless. If we are Boeing, then we can do it, but otherwise, if we don't have infinite money, cheat code, then we cannot. First stage, this is the expensive part. We want to keep this one because first stage represents 75% of all the expenditures. And we are just ejecting it at 80 kilometers, and after that it falls into the ocean, and then fishes will be happy because they can get an additional engine. But since engines are the most expensive part and the fuel tanks here, then we should save it. Obviously, first stage contains not just the engines, but the fuel tank and the oxidizer tank here. It can be manufactured from an aluminum lithium alloy, which is, I can say cheap, but it's way cheaper than carbon composite. Only 2 companies are using carbon composite. Rocket Lab, which is flying regularly, it's a publicly listed company. The other is Firefly, who is exploding regularly and sometimes flying, but they are a newcomer on the market, so right now they can do it. And they will also land on the moon, so they got some contract from NASA to be in this business as well. Second stage, this is only representing 25% of the cost. In this case, we need only one engine. This is completely enough to serve our market at low Earth orbit. And in this case, the speed, the energy, and everything is so high that we don't want to recover this. So everything would be so heavy that, okay, let's forget it. We are burning up only one engine. They are just losing maybe $20 million or less than 20 million, so it doesn't matter. Also, this cheese represents the cargo. Doesn't matter for us, it's coming from our business partner, and there is the fairing, which saves the cargo from the atmospheric drag, and we are ejecting it. Also, SpaceX collects it. At the beginning, they tried to catch it with a net on the top of a ship, and maybe they were able to catch it once because it falls to 2 pieces, so 2 boats were chasing the fairings. Nowadays, it just flashes in the ocean and then fishing it out, and they were able to realize that it's much easier to make it waterproof than catch it. So, our objective as an economist will be to motivate our engineers to make the first stage reusable. So this should land propulsively. You cannot use drag chutes or parachutes because this would fall to pieces. SpaceX once did it, tried to do it, but it was exploding way earlier. Rocket Lab tried to do this because they have smaller rockets. They tried to catch it with a helicopter, but it was also a disaster because everything was moving around. So nowadays they are also just fishing out from the ocean. We don't have to use the solid rocket booster part because this is expensive, so we are just using proper engines, and we don't care about the second stage much because it's expandable still. Still, we have to think about the fuel because obviously engines need something to eat. So liquid hydrogen is the usual for all space industry because this is energy dense. Just the problem is that that's why we don't have hydrogen-driven cars and other vehicles, because hydrogen is absolutely nasty. So you have to keep it at really high pressures, at really low temperature. This is absolutely corrosive, leaking everywhere. So we can find a lot of rescheduled space shuttle launches because it was leaking. Or also the Artemis SLS program was also rescheduled many, many times because hydrogen is just flowing out and yeah. So you don't want to work with hydrogen. Kerosene is better because it's less cold, but less energy dense, and also it makes a lot of dirt in the engines, so you have to clean the engines out whenever you would like to reuse it. This is our limiting factor for SpaceX as well nowadays, so they can return a rocket to launch pad, or at least the first stage, only after 2 weeks. In the past it was 3 months, but now faster. So that's why the industry is moving towards liquid methane. It doesn't matter in China or in Europe or in the US, because liquid methane is more energy dense than kerosene, but you need less cooling, lower pressures, and this is just natural gas in a cleaner form, so easier to purchase. And still, if the tank ruptures, then you have huge kabooms, as sometimes we can see at SpaceX test facilities, but it's nice. So we have all the data in the description. In this specific case of old and new space, in so-called old space, we find legacy hardware manufacturers. Some of them are operating, all of them are operating both in defense sector, in aeroplane manufacturing, and also in rocketry. So they integrated. They were long time ago. Some of them were operating as separate companies, but after that, to reach the level of economics of scale, and also because there is a small set of public procurement processes and projects, so that's why to survive they had to merge together, and that's why we can see in many cases monstrosities like Boeing, which is a disaster, what we can see after its merger with oh my god, which was the other party which ruined Boeing? Yeah, McDonald's. So they are the legacy companies. Or for example, United Launch Alliance is even stranger because Boeing and Lockheed Martin was competing during the 90s with their own rockets for some Pentagon contracts. And obviously they tried to cheat, so there was corporate espionage, they tried to bribe politicians and so on. So at the end of the day, they were forced together to merge their rocket business. At least the service provider had to be merged, and both Atlas V, which was using Russian engines, and both Lockheed's Delta IV Heavy had to be acquired by United Launch Alliance, and nowadays they would like to sell it because ULA is still it's limited. So sometimes they were able to go on commercial markets, but once it was eaten up by SpaceX, then nowadays they are just forced to serve government contracts. And even they were developing their new own rocket, the Vulcan, but right now they are for sale, but nobody would like to buy them, so this is another issue. Northrop Grumman, they are completely coming from the defense sector. They are absolutely not in civil aviation, but they were acquiring Orbital ATK, which was satellite manufacturer, and also ATK part was in the weapons business, and Orbital originally got some NASA contract also to develop launch vehicle, and sooner or later, after 2 acquisitions, now everything is owned by Northrop Grumman. And after that, we will come back to this story again because they are also strange. Focusing on Europe, we have the monstrosity which is dominated by Airbus, BA, Arianespace, Safran, and also Leonardo. At the end of the day, the launch vehicle is supplied or supported by and integrated by Arianespace, but the parent companies are also Airbus and Safran. Safran is an engine, mostly aircraft engine manufacturer, but you can see in civil aviation, Airbus is manufacturing practically everything which flies. Somehow, BA is absolutely in the defense sector. In case of Leonardo, this is also a monstrosity just in Italy. So you can buy railway safety systems, satellites, small rockets, everything from them. So they are also a general manufacturer. And also, they are even manufacturing the logistic module for the US lunar program, and also they are manufacturing unmanned cargo ship for Northrop Grumman. The last one was dropped, unfortunately, during the logistic part from Europe to the US, so they had to manufacture a new one. So that was an expensive oopsie. Also, we can see the Indian ISRO. In this case, we can see that the space agency and the manufacturer is the same. So we don't see it in Europe or in the case of US at all. But it's way cheaper. So they are way more efficient in case of manufacturing than all the big fat cats in European continent or in the US. We can see also Mitsubishi Heavy Industries for Japan, also China Aerospace Science and Technology Corporation. They are providing for the government, but also we can see on the other side of the table that there are many startups also in China. CRS, they are completely in the weapons manufacturing sector. They are trying to come into the space business. They have a strange shuttle which is always flying during the next year. So right now there is a huge competition which will happen earlier. They are flying or Hungarian Euro adoption. Right now they are head to head. So everybody is coming from traditional aviation and defense, and everybody since the 60s get used to the nice, juicy public procurement processes and projects where you can get cost plus awards, which means that, okay, you can get the contract, you have to deliver the rocket, ship, space station, whatever, you have to deliver the cargo, and it's purchased by the government agency. And of course, there will be cost overruns at the end of the day. There will be late deliveries. So this is, and of course, some nice corruption. The best example is that when the NASA SLS program was announced, they were saying that, oh, it will be cheap because engines will come from the space shuttle, so it's literally on the shelf. The solid rocket boosters will come from the space shuttle, just we are adding one more segment, that's all. The fuel tank will also come from the space shuttle, because it's
still hydrogen fuel tank. So what can possibly go wrong? So practically all legacy hardware is coming from the space shuttle, except the small spaceship on the top of it, which carries people, but that was already finished, so it was no problem with that one. And also the launch tower will also come from the space shuttle. And then they spent 800 million US dollars to repaint and refurbish the launch, this Crowley launch tower thing, which is moving, so not just staying stationary, but it can drive in to the vehicle integration facility and drive out. So, but they spent 800 million US dollars, and also the whole budget of the program is nowadays around 8 billion US dollars, and no one was flying yet. So they had just one automated mission last year, and that's all. So, and one launch nowadays costs around, or assumed to be cost around 2 billion US dollars. So this is public procurement process. Then we are doing the cost plus over the business model. No deadlines, no budget. Taxpayers pay whatever you want. Because also the equipment is unique. And quite terrible. So one of my friends was asking me that, why don't we have space shuttles anymore? It was so good. No, that was a nightmare. So in terms of reliability, not just because it was exploding sometimes, but because you had more delayed launches than no delays, and also engines were sometimes destroying themselves, just they were lucky. So no, that was an engineering and especially a financial nightmare. So this is what they wanted to avoid under the second. So once Columbia Space Shuttle exploded, they realized in 2006 that new space, at least new contract terms should be designed. So that was the Space Treaty and Space Act. And in this case, NASA was able to create this fixed price contracts. So they were looking for companies, because everybody has always big mouths when they are saying that, oh, we will revolutionize space travel and it will be cheap and easy and you will have a nice presentation, it's fancy, and after that nothing happens, obviously, because they are waiting for public procurement processes. In case of fixed price contracting, they were saying that, okay guys, there is 800 million US dollars on the table. You can get half of it if you are able to put half of it also into the company. So it was like a venture capital investment, just the NASA did not become owner. So it's seeding capital. That's the difference. They can get technology assistance. You have to develop a launch vehicle. We don't care what. Somehow you have to throw stuff to the International Space Station with some vehicle. You will own the vehicle, and you can get only this money. And once you are able to reach, so you are able to dock in with the cargo to the International Space Station, then you can have a chance to get the contract. And in this case, in the contract, we will order 12 deliveries with a defined amount of tonnage, with a defined amount of time span. And in this case, you can get also 100 or 120 million euros, something like this, for each deliveries. But we don't care about the technical difficulties. We don't care about cost overruns. In this case, the private company will run all the risks. So number of missions, capabilities are defined. Launch vehicles are operated by the firm. They can use it for their own commercial needs. Doesn't matter, they are not limited in this one. And the cost overruns are absorbed by the firm. So like in the ordinary business environment. So it's not when you are just milking taxpayer money. And suddenly there is a boom on this front. So obviously the first was not SpaceX, it was the rocket lister, but they were not able to collect enough private equity, so they were dropped down from the zero. round. So SpaceX was the first company, practically. Also in the first round, Orbital but they were already in the sector, so they are not literally startup, because SpaceX was funded in 2002 and they got the contract in 2008. So they were also in the startup phase. But after that, Orbital was purchased by Northrop Grumman at the end of the day, so they went to old space. Also, nowadays, we can see here Rocket Lab, but they are in the small sub business. So everybody was thinking during the late 2000s that satellites will be so small that you just have to deliver several hundred kilograms to orbit. Nowadays, they realize, because now they are manufacturing and developing their own medium lift rockets where you can deliver tonnage, because at the end of the day, nowadays, okay, satellites are smaller, but the big business is that you have to fill all the cargo bay with satellites and just throw everything into space when you are in orbit. So must deliver. It's like when someone is delivering pizza, you are not just delivering one pizza, but you are trying to stack as much as possible to improve efficiency. But Rocket Lab is on the stock market, so it's publicly listed. They are flying, sometimes exploding, but otherwise they are nice people. So this one is not a scam. Speaking of scam, Virgin Orbit finally is dead. Also, Virgin Galactic is quite, I don't know. So it's like a money laundering machine, because at least they are not using public procurement money, so not using public money, but they burned out a lot of private investors' money from venture capital funds, from stock market investors. So that was quite shady. So they had 6 launches, only 2 was successful. Then they were running out of money, and even one angel investor checked their finances from Texas. He was some kind of a famous guy, and he was even saying no. So after that, the assets were liquidated. They were leasing one Boeing 747, and they were trying to launch a small rocket under its wings, because in this case you can spare the first stage. No, they were not able to do that. It was always exploding, and also cargo capacity was absolutely limited, so it was utterly useless. Finally, they are dead. Blue Origin, yeah, this is Jeff Bezos' company. It's even older than SpaceX. They have this really strange, aerodynamically efficient shaped suborbital launch vehicle, where they are launching space tourists until 100 kilometers. Then they are just dropping them, and after that they are landing somewhere in the desert. So practically this is just a theme park equipment, but they are operating, but it's quite reliable, and also they can reuse the whole rocket is just one stage, but this is for suborbital missions. So now they are developing their own big, heavy orbital class rocket. It had only one launch. It was partially a success because it was not exploding on the pad. But they would like to recover it, and they would like to install all the satellites for Amazon's Kuiper satellite internet constellation. But yeah, we are waiting for it. So they have enormous amount of money, enormous amount of resources, just we cannot see right now any kind of an end product. So they have beautiful hardware and everything, just without delivery. And also this isn't public, this is private company, it's not publicly listed. Firefly, originally it had Ukrainian owners, then Pentagon forced them out. So right now I don't know who is owning them, but they get also many Department of Defense contracts. So they are not part of NASA deals, but also NASA later extended this fixed price contracts, because if you are able to deliver some instruments on the moon with the moon lander, autonomous moon lander, then you can get again money from NASA. once you are delivering. So in this case, again, launch costs are funded by the firms, developing costs are funded by the firms. We get some technical assistance from NASA, and mostly what we were able to see until then, it was beautiful craters on the moon here and there, because everybody was, or they were landing and just sideways. Only Firefly was able to land in this year. So that part of the company is successful. Launch business for them is still in the early stage. Okay, in Europe, we have PLD space. It's in Spain. I think they already have their explosion, or they are at least close to launch. Also, we have ABL space. One of them was exploding, I don't know that. Yeah, so they are close to the first launch, or they are already did something which was not successful. Then we have Rocket Factory Augsburg. They are really nice people. They were coming completely from the car manufacturing sector, so from the automotive sector, and they would like to. They are saying that okay, we can manufacture things from car parts at least with the same equipment, and this is how they would like to cut costs. Because in many cases, people are saying that oh, it's space rated. It's like my laptop that is military rated. It means that it's made from the cheapest components and maybe it's not falling to pieces immediately. So in many cases, price tags are part of price tags are imaginary. Also, we can see Skyroot, it defaulted, just somehow recovered. Orbex is also from Europe. I know that Galactic Energy One Space is from China, and one of them is already flying, so they started to deliver commercial cargo into space for Chinese companies. Astra is a joke, I just kept it here. They were able, so people were joking because they are space Epsilon. So SpaceX is always launching upwards. Astra was able to launch sideways. And then exploding, obviously. So I think that they were maybe launching 6 times and never able to. So sometimes they were able to reach orbit, and then second stage was exploding or not igniting. So they were never able to deliver any kind of a cargo. Even NASA told them that, guys, forget. So they had to pivot out completely from rocket manufacturing. They were lucky because until they got VC money or still had venture capital investments, they were acquiring some satellite manufacturer companies, and right now they are manufacturing ion engines for satellites. So still they are saying that, oh, we will develop a rocket soon, but nobody believes them. And also, even they were forced out from the stock exchange. So NASDAQ told them that you have to go to private. Once stock prices were really close to zero, so even they had to go in the complete turnaround. So we have really, really strange stories here and there. I already mentioned. Oh, yeah. So commercial resupply services, they were hoping that they can build up the new space. But at the end of the day, we can see only SpaceX was delivered with this contract. So Orbital Sciences, they were buying engines from the Soviet moon program, refurbished engines which were corroded and then exploding. So they had to import after that Russian engines from Ukrainian fuel tanks. The cargo ship is coming from Tali or Leonardo, Thales or Leonardo, one of them from Italy, from Europe. So they are just integrating the whole thing together. And after that, they are billing way more money for cargo delivery than SpaceX. So they are lower launch numbers. Right now, they don't even have their own launch vehicle because of sanctions, and the war. So right now they are launching on SpaceX rocket, even if originally their job was to develop their own rocket. So it's also kind of miserable. Speaking of miserable, NASA was also thinking that, oh, in until 2000, so Space Shuttle was retired in 2010. So new rockets are developed, and then they start to deliver people on the International Space Station. Obviously, some delay happened, so instead of 2011, first delivery happened in 2020. So in this case, when my team, the previous team, told me that I should become a professor, I mean full-time tenure professor, within the next 5 years, and it was 8 years ago, I'm not in such a delay. Speaking of this one. So in this case, what happened that obviously, until we are just launching cargo, who cares? If it's exploding, then insurance company will cover it, some part of it, but at least satellites and cargo is secured. The risks are just the operators. If you're launching people, then obviously they have specific needs, so they have to limit the G loading. They need atmosphere to survive. It's good to have some toilets on board. It's not good if you are exploding them, so they have to survive. So that's why NASA was really careful. So in many cases, these programs were slow because of safety. But still, we can see that they spent $3 billion until 2014, and after that, okay, first automatic launch happened in 2020 by SpaceX, but since then they are happily delivering to NASA and also happily delivering to private companies like Axiom Space, and there is also another one which I forgot to mention, even there. So that's why we can see that it's 5 for NASA, 1 for private clients, and so there are already firms which are buying seats and complete missions. We can say that, okay, it's cheaper or not. In this case, you can, or NASA can buy it for $88 million per seat. For a Soyuz, it's $76 million per seat. And still they are doing the rotation that one US astronaut is flying with the Soyuz and one Russian astronaut is flying with the Dragon for an exchange like this. But also Dragon can carry cargo as well, so not just people, but also it's a mixed cargo delivery and it's way bigger. But speaking of disasters, Starliner, so Boeing obviously got the contract there, building everything since the beginning of the space program in the US. So after spending $4.2 billion in a fixed price contract to develop and operate, and additional $2 billion from their own pocket, they had their first launch in 2019 when they realized that nobody did any full system check. So there was no integration check, no simulation, something like this. So vehicle was reaching orbit autonomously, and then the computer was thinking that, oh, we arrived already on the space station, so fuel vented, engines were off, and then the whole thing started to fall back into the atmosphere. So it survived, but there were really angry people at NASA. So second uncrewed flight, they had thrusters failures, but it was able to talk to SpaceX, so okay, milestone was reached. They were able to get some money. Then first Boeing test happened last year. Also thrusters started to fail, so at one point it was questionable that they can get, they are able to, in this case astronauts, 2 people were on the vehicle, can they dock to the space station? But if they are not able to do that, then also they cannot come back to Earth within designated timeline because these thrusters are using in both directions. So after that, obviously NASA told these astronauts that you are staying there, and after that they were coming home. Instead of 2 weeks, or sorry, 1 week, 9 months later they were brought back by SpaceX once they had free seat. They had to reschedule all the other programs. So in this case, NASA told Boeing that we will not pay for this mission again. So right now, this is a huge mess, what we can see here. That's why I'm saying that, so Boeing had issues also in civil aviation, but also here as well. So the company is in a disastrous shape. Yeah, this is Falcon 9 and the Dragon. This is a orbital ATK's vehicle, which at the time Antares when it was not exploding, and this is Boeing Starliner on an Atlas V rocket. And also, I failed to mention here, so Atlas V is human-rated, but since it uses Russian engines, it will be phased out soon. So there are only 10 vehicles existing. So they already manufacture them, it's just in the warehouse somewhere. So sooner or later this vehicle will also run out of rockets because the new rocket is not human-rated yet. So, okay. Yes.
Can you go back?
Yeah.
The price changes in the orbital launch businesses.
Yeah.
I mean, you talked about it a lot, but then what are the reasons behind the price changes? I mean, we have like the points, NASA fixed stuff, but then I'm not seeing like the reasons for the price changes in the orbital launch business.
So the key problem is that mostly late delivery. So if they are delaying, then they can say that, okay, we would like to ask more money to maintain the manufacturing line, to maintain the test facilities, to refurbish the launch towers. Also, many components has finite shelf life. So there are many exploding bolts or even thrusters where you have a finite lifespan. After that you have to change it because or batteries or battery systems, power packs, where you can't just keep them in the vehicle. You have to exchange it frequently because otherwise it loses its reliability. So also development costs, so they are saying something during the project proposal, and later on they realize that this will not work that way, so they have to change technology. Things will get heavier, then they have to take other things out. So so the problem is like in the case of construction business, that until you are building a house, it's still close to standardized, but also it can be issues. But if you are building, let's say, a highway, which is unique, then maybe soil will be different. Maybe you have to stabilize half the mountain. So some hidden things will come out, which could be avoided by precise planning or precise engineering. Just you can't have full knowledge about the whole thing. And in many cases, they have to invent things which are not existing. So there was one participant which was dropped out, one of the even fixed cost procedure, that they were trying to participate, but they had negative weight for some components. And even NASA told them that, okay, if the vehicle is already too heavy, then you should not participate with the procurement process. So the problem is mainly with uniqueness, and also the problem is that you have to develop many components. You have to write softwares which were not existing before. So yeah. So if you are looking on the business right now, so not just the number of companies and who is saying what, but from financial point of view, what matters is launch fees. So and capacity doesn't matter much. So I collected everybody who is delivering stuff to orbit, but mostly cargo weight is like limited is around 3 tonnage. So even if you can launch 27 ton, mostly it's unused. So because usually you are filling the volume of the launch vehicle earlier than you are reaching the tonnage. So you're not And hopefully they are not launching rocks into space or concrete slabs or pack of water to reach this. If you are manufacturing a space station, you need something like this, or if you are going to the moon. But in our business case, it doesn't matter that much. So we can say that yeah, the H9 rocket in Japan, it has only 4 tonnage of cargo capacity, but this one is completely enough for delivering cargo to low Earth orbit or even to geostationary orbit if you are just launching satellites. Or they have their own cargo ship to deliver to the space station as well. 4 tonnage is completely enough, so the rest is overkill. Ariane 5 was absolutely over-engineered. They were thinking that, and in many cases, they were launching 2 satellites at the same time. So 2 heavy satellites could be stacked on the top of each other. But nowadays, since satellites are way lighter, again, the volume was an issue. So you can see that, okay, has been scaled down in the case of Ariane 6. Price tags. Price tags are the problem. So we can see that everybody is around 100 million US dollars and a bit more. Again, in Europe, Ariane 6, when everything was approved in case of the project, they were saying that, oh, it will be just 70 million. And now it's again 100. So yeah, manufacturing is hard, and also if you are throwing away everything after the first 10 minutes, it's hard again. So we can say that Proton M is cheap, but they are manufacturing it since the 60s. And also it's hypergolic, so all the fuel and oxidizer are absolutely carcinogen, poisonous, so you can't put people near to it. Also, you can see the reliability is with problems, and also right now they are not able to sell it on the commercial market because of the sanctions. In case of the Indian Space Organization, now they are ramping up the GSLV launch vehicles. Also, we can see that it has limited weight capacities, but at least this is completely manufactured at home. They are owning everything. So this is completely a vertically integrated company, just it's state-owned. And yeah, in case of new space, we have the Northrop Grumman something Antares whatever, because it's retired. So this one is not existing anymore. They have to buy engines from some US manufacturer, but also the engine was not tested yet. So I'm suspicious that can we see anything in the future. Rocket Lab, yeah, they are small satellite launchers, so it only has a capacity of 300 kilograms. But when they are delivering a huge swarm of small satellites. So not just one, but they are putting everything to orbit with multiple ignitions. But also we can see that they were failing 4 times quite randomly. So sometimes they have really good years, sometimes they are unlucky. And yeah, here we have the SpaceX. So they were saying, and we are trying to follow the same thing, that okay, first stage should be reused. So they have 9 engines in it. So this is expensive. The first stage, the manufacturing of the first stage, and also all the big tanks are into it. So practically they are launching, turn back, and then they are landing. In the first 2 years, I was able to see beautiful explosions. So this is when I started to focus on this business, because it was nice. But after many iterations, so right now, Falcon 9 is still called Falcon 9, but this is the Block 5 version, so this is what is flying reliably. So in the Block 1, 2, usually they were able to fly upwards, just they were not able to recover anything. But now the engines are absolutely developed, so it's really hard to find any kind of an engine failure. They are the most reliable engines because they manufactured a huge mass of them. So it's and it's also quite simple. It's not complicated. And what is necessary for propulsive landing? Obviously, that you have to throttle down. So you have to be able to slow down the vehicle, and you have to have only 3G loadings. And we are talking about a rocket which has a size of a 10 storage building. So you have to slow down the 10 storage building and then land on the feet, and not just on land, but also in the ocean on a barge, because autonomous drone ships are also used, 3 of them, because in this case you can launch heavier cargo and still land easily. So they had to pay the price, so they had to spend 2 years. Everybody was laughing on them. But once they started to deliver, nowadays we can see that now it's boring. So at the beginning, everybody was watching launches. Nowadays, even I'm too lazy to watch everything because it's just going up, going down, and doing their stuff. They're above 500 launches. We don't have 500 launches in any platforms since the beginning of space age. So, and they were able to just do it within several years. Also, pricing. So, if you are buying an expandable Falcon 9, now it's really rare, but still sometimes we can see that they are selling old vehicles after 20 launches or 10 launches. You can buy it for 70 million euros, so US dollars. But mostly everybody is using flight-proven hardware. So after 1, 2, 3, 4, now we are reaching 30 reflights. That's some equipment. They are selling just for 30 million US dollars. So that's the reason that nowadays they are completely dominating the launch market. At least the market oriented, also not the when we are talking about public money, but when it's about private money. SpaceX has the majority of the cake, and also Rocket Lab is just picking up the other pieces which are dropping off from the table. So they created their nice monopoly, and the rest of the market is just waiting there. So we have really agile startups who are still not flying, so unfortunately, practically in the whole planet, so in Europe, in China, in the US as well, but right now they are in the stage of monopoly. In case of Europe, ESA initiated also their own seeding capital program, so they are trying to force Airbus and Arianespace to develop also partially recoverable launch vehicle, but again they have to develop the new engine for that one, so that's supposed to be the Prometheus engine, and also a whole new vehicle for that. And I can't say that I was able to find any other proof than some nice white papers that they are working on it at all. So no engine tests or nothing. So it's So in our case, we have to pick up this set of disasters for taxpayers' money, and we have to refurbish Arianespace like a good economist. So obviously they have the current Ariane 6 launch vehicle, which was finally debuted after 2 years of delay. And somehow we had to cut launch costs. And in this case, we can do for new launch platform design. So we have to play with modularization, and we have to Lego up for vehicle. So I will give you a lot of numbers, so different engines, what is their price, what is the required fuel, and after that we can and the groups can put together their own launch vehicle, and after that we can test it. Okay, how does it work in case of revenues and also in case of expenditures, and then after that, once you settled with some kind of a launch platform which supposed to be price, then after that we can start to test this company that, okay, what is the valuation, survivability, and so on. And we will always go back to the original company to see that how this company performs at the current or similar standards. So we can see the added value of your proposals. Yeah, this is ESA. Mostly everybody forgets it, but European countries have their own NASA as well, and we have even Canada in this thing. So for the case study, we have the following candidates. So you can use whatever you want from this table. Obviously, if we are buying from the US or from Russia, let's assume that we can buy from Russia. You have to buy it for US dollars. So this is how we can get part of our foreign exchange rate risk. The other part is that Amazon was forced to purchase, at least to diversify their Kuiper satellite internet launches. So literally one of their investors brought them to court, and they were forced to diversify. And this is how even SpaceX got some launch contracts, but also Arianespace got also some launch contracts. So this is how we were able to deliver at least 18 or 16 times for nice US dollars. So this is our place to shine because we can milk Amazon. And what we can see here, these engines are already sold commercially. Okay, not the Merlin one because it is only used by SpaceX, but in this case you can assume that we can use it. Prices, I digged up the internet, so these are the most reliable price data. And I was forced also to watch a lot of interviews with Musk, so you're welcome. And in this case, we can see also fuel requirements in tonnage. Practically, fuel is marginal. So when we are thinking about fuel, it's like 100,000 US dollars. Okay, it's a lot from me, but compared to the 10 to 20 million US dollar manufacturing costs, this is quite low. So that's why it doesn't matter that we are using kerosene, hydrogen, or whatever. From economics standpoint, they are the same. So we don't want to save fuel. Otherwise, if you are thinking about carbon emission, right now spaceflight contributes less than 1% of greenhouse gas emissions. So, and even if we are using hydrogen, that practically we are just creating water vapor, so not even CO2. If we are burning kerosene, yes, we are making CO2, or if we are burning methane, at least it's more cleaner, so we don't make sluts, just CO2. It's cleaner. But since we are economists, we need probabilities of success. So probability of explosion or rapid unscheduled disassembly, so RUD. In the case of different engines, they are adding some risk to the game. Obviously, if something is flight proven, then it's better. But since these engines are legacy hardware, so most of them, that's why I had empirical data, so these probabilities are also empirical probabilities. This row we can completely ignore, so can it land proportionally, so can we slow it down? So the biggest problem with jet engines, gas turbines, and also rocket engines, that they are behaving mostly well at 100% thrust, or close to it. So they are the most efficient, their cooling is operating at best, So it's really, really hard to slow these things down and keep them alive. Okay, in jet engines, they can throttle down, but mostly they are also using higher power settings because this is when the engine is efficient. In this case, we don't care about efficiency or engine efficiency because we are not flying passengers through the Atlantic Ocean or other places, but mostly physical wear and tear. It can destroy the engines. On the other hand, these engines should just operate for minutes. So we are saying that, okay, I'm reusing the Merlin 1D engine, but this Merlin 1D engine was operating on the test bed for 3 minutes. After that, it was integrated to the vehicle. It was operating for 8 minutes. Landing is several seconds, so let's say 1 minute. And after that, you are, or at least they are running diagnostics. They don't have to take it to pieces because it's full of sensors. They are just cleaning it, and after that, the whole vehicle can go back to the launch pad. So it's not like when you are running an engine, an airplane for hours, and after that, after defined flight hours, you have to refurbish something. We are talking about minutes here. So different case. So in this case, we can say that they can land propulsively. Also, we don't care about stability of landing. So obviously, if you have more than one engine, but if you have two engines, it will be quite hard to land because of asymmetry, possible asymmetries. This is an engineering problem. It is not an engineering class. You can put as much engine as you want. So that's no problem. Just please, in the second stage, only put one engine. Once a team tried to put their 5 engines, I don't know where they wanted to go because Pluto mission or something like this would not require such amount of engines. But okay, otherwise it was nice. Mass production. We can say that all of them are in mass production. So Prometheus is still doing investment terms, but we can ignore this one. So you can say, if you want, you can use it. Launch success to failure ratio. I did not update this one, but doesn't matter. So we can say that most of them are absolutely reliable in most of the cases. So launch and land ratio, now this is absolutely old, so we are now in the 400 region of landing. But what is cannot be ignored, that probability of explosion during the first year, second year, third year, fourth year is flat rate here, but still here we have the learning curve. Since we don't have much data, I was taking this learning curve from SpaceX launches and landings, and this is what we were able to see, that at the beginning, more than half of the vehicle, you had less than 50% chance for landing successfully, and after that, once they were able to solve it, then they were able to adopt the technology easily or with the relative ease. So this is upwards probability of failure. This is downwards probability of failure. So we should at least deliver into space, and after that, if we can save money, we are happy. If we are not so happy. Also, the case study was calibrated that we can reuse rocket 10 times, at least the first stage 10 times. Now, maybe we could extend it further because now we are reaching the 30s in case of SpaceX Falcon 9. So, but okay, let's keep it 10 because it's easier for calculations. Yeah. So, as I mentioned yesterday, if some companies would like to scale up their vehicles or their engines are too weak, then they are adding these solid rocket boosters next to it. As you can see here, that was the time when Northrop Grumman wanted to build a big solid rocket booster for a Pentagon contract. And even Department of Defense told them that after seeing this beautiful initial sentence when half of the vehicle was exploding in the up section, that we don't need this. Please. It was cheap. So just even the Pentagon was saying that it's a no. So the problem with solid rocket booster is, okay, it can be cheap, just you cannot turn it off. So once it's running, then it's going through it has a positive, or it has a feedback mechanism. So once it's spinning up, then it's just delivering this grain, this stuff of solid burning material, and after that it will just burn and burn until it runs out of fuel. So this is a great risk, because if it has any kind of a problem, then it can lead to disasters. At least you can slow down, or you can turn off liquid propellant engines. So nice concept, you don't want this. So we are ignoring it, and also this is expensive, so that's the other part. It has only one manufacturer in Europe, in Norway, so we don't want to step into another monopoly territory. In case of propellants for liquid fuel engines, what we were able to see before, we can choose kerosene, so RP1. It's like what we are fueling into jets, just more cleaner or refined, more expensive, but doesn't matter. Last time when I checked it, it was at this euro to tonnage price. It's good because it can be stored in room temperature. Also, in practice, they are cooling it down, but from economics point of view, it doesn't matter, but it's a bit dirty for the engines. In case of hydrogen, as I mentioned, it's more expensive because you have to keep it really cold temperatures at really high pressures. Boils off means that if it boils off, that it means that the temperature increases of this really cold stuff, which means that the pressure will also increase. So that's why it can rupture the whole tank. So it's quite risky to deal with hydrogen. So that's why the industry right now is, during the last decade, moving towards methane, because still 160 Celsius is the operational temperature, so not minus 250. And also it's really cheap. So that's why. And also it's burning cleanly, so we have really nice blue flames when we can see an engine which is using this thing up. And also we don't need oxygen, because it can be manufactured. So if you have electricity and the necessary equipment, then you can manufacture in oxygen on site. So it's really cheap. You just have to purchase the fuel. Yeah. So, okay, we have the tonnage fees, rocket body. So Rocket Lab has, and Firefly, they are only the manufacturers for composite bodies. It's way lighter, so half of the weight than the aluminum lithium alloy, but it's really expensive. So I was looking for many different sources, and that was the best guess what I was able to come up with from different databases, different forums on the internet, and so on. But also it can be really reliable and durable. Personally, I don't like carbon composites that much, because the problem is that if you are using metal, then if you have metal fatigue, you have cracks and so on, it starts to be bending, but still it remains intact. In case of carbon composite, you have the intact thing and then it will explode. So rupture is imminent, and sometimes we can see that people are making fuel tanks or gas tanks from carbon composites, and if there is any failure in manufacturing, then it can explode without any kind of a warning. So there is no leak or anything like this. It will be always a catastrophe explosion. So originally, SpaceX wanted to build the spaceship from carbon composites, and even they were abandoning the idea after testing it on sea, that what happens if you are building huge fuel tanks from carbon composites, and that was the last time when we were able to see the barge to go out for the sea, because it was not ending well for them. Okay, nobody was in church, just one ship minus. So that's why light, but yeah. So the traditional aluminum lithium alloy is quite relatively cheap, and also the problem is that bearing of structural loads can be a problem. So there was one case when SpaceX was losing one vehicle during launch because structural load-bearing rods were collapsing during the launch. They were at 30 kilometers, 40 kilometers, but that was when maximum aerodynamic pressure was hitting the vehicle, and they were still accelerating, and the whole vehicle just collapsed on each other. So it can have its own risk, but we can see also probabilities of failure. So if you have also if you are manufacturing carbon composite, this will be manufactured completely by robots. So literally they are sewing together pieces. So robotic heads are just spinning around the shape of the component and then just gluing stuff on the top of each other. So it's really strange. You have to invest a lot into robotics to solve this problem. And reuse. So we are using the first generation of partial rapid reusability, because if we can save the first stage, then it's completely enough. And after, it's so cute, 1 month is inspection period. Nowadays it's less than 1 month, not 2 months. Written there. Also, a rule will be just reusing 10 times. Now it's way more. But we will lose the second stage and also the one engine which leads there. And of course, we will have this learning curve here. We don't care about total rapid reusage. What right now is tested by SpaceX, and finally the second generation of starships were not exploding, not even the second stage. We have beautiful explosions this year, but finally they were able to go through the whole suborbital launch test flight procedure. But yeah, that one is really hard because you have to use heat ties, you have to use some kind of a propulsive landing for also the ship. So we don't want to solve that. If we are able to achieve this, then this is completely fine. Right now, some Chinese startups are really close to do propulsive landing, so we don't have to invent anything. But some things can go south. So here the landing gear collapsed, for example, on the sea. So they were happy for 1 second that, yeah, to survive them, until it didn't. So, or when it was like this Geoffrey Baker fin was tugged in one place, and after that it started to turn around, so it was also bad. But this is our potential market. So for the next, okay, originally the case study started in 2022 because the launch vehicle was supposed to fly also that year. So I collected the data from the launch manifest, so orders for Ariane 6. So these blue bars are representing the market order for the next 5 years ahead. So in the first year we can have 4 flights, then 5, then 5, then 5, then 2, then 1. Which is not the recipe for business success. But if you are able to go down in pricing, so this is above 80 million euros, if you are able to go down within the range of 6 to 80 million euros, then our numbers will increase to 4, 10, 15, 12, 10, 6. So obviously I was just multiplying the numbers to have bigger market share. And if you are able to go in SpaceX levels, so under 60 million euros, then we have some potential to grow. So this is what we can see here. Obviously, we cannot launch more than 52 times a year because we have only one launch pad in French Guiana in Kourou, and we cannot build a second one because already we are struggling to survive. So, and one launch per week is completely enough to deliver everything there, to integrate, to wait for good weather, and so on. So this is the natural limit for our growth. But it's still nice. We can deliver. So this is, if you are able to cut launch costs through modern equipment, then we can set our objectives. So these are the tasks that we have to design the vehicle. Okay, we have to just fill up the table with equipment, and after that it will be calculated by the Excel sheet. What matters for us, because we are economists, that how profit and loss statement will look like after this one, and then how value will react on this, how foreign exchange exposure will be reacting on all of this, and interest rate sensitivity will react on all of this. So I wanted to show you a nice story of commercial space, because right now this is the big thing, both sides of the ocean, and also in China. And also, since it's my hobby, that's why I was able to collect a lot of numbers, real numbers, and not just making up numbers for the case study. Okay, so going back to our initial problem, that low launch cadence, we can increase it because if we are able to reuse the first stage, then we can have low prices, and that's why we can increase our launch numbers. And also, we get this contract from Amazon, since the port was forcing them to diversify their launch businesses. So now we will have 18 launches on Ariane 6, which means that this is coming above what we were able to see, and this is billed in US dollars, so it will be nice. That's why I get the happy hearts. Okay, how can we do the discounted cash flow valuation? Obviously, now I uploaded the lecture notes on CoSpace as well, but still I wanted to make a beautiful graphical representation for all the things ahead of us. So that was the best what I was able to come up with. So we are looking forward only for 5 years ahead. This is enough. So if we are checking different textbooks, they are always saying that, oh, 5, 6 years, that's enough. I'm pessimistic, so 5 years of revenues. We know the quantity, we know the price. Also, we know the expenditures, because we have only one launch vehicle. We have a set of facilities. So also, this is an existing company, so we know how many people they are employing, what is the expenditure structure. So that's why it was also good. Fixed costs. So we have to keep the facilities open. We cannot close anything. We cannot fire people, because I have no idea who is relevant for the business and who is not. So, and it's also not HR class, so we are keeping the people. We are not United Launch Alliance. United Launch Alliance was able to cut launch vehicle costs because they started to cut wages. So they were saying people that, oh, we have to be competitive, so now you are earning less, and also your pension fund will be used up, or some part of their pension fund will be used up. So no, we are not doing this. yeah, not the ULA. So fixed costs are there, we cannot modify them. At least we will try to get rid of some of the related assets by using lease contracts. So selling it to a lease company and leasing it back. So it's a lease back. What we can try to get funding, or at least part of the ways how we try to solve funding. Variable costs, this is related to the flight cadence or flight numbers. So obviously the number of manufacturing needs will determine the variable costs. Of course, depreciation should be accounted. And after that, interest paid, lease fees, hedge expenditures will determine the pre-tax profit. And also part of this will be recognized in the free cash flow, because depreciation is obviously not a real expenditure, so it should be added back. Also, we have to recognize corporate income taxes in the interest payments. So after some modification, we will reach the free cash flow stage, and then we have to discount each year's free cash flow with the weighted average cost of capital, which is here. And to calculate the weighted average cost of capital, we have to pick how much equity are we using now, how much debt are we using now. Right now, the company is not in debt. So they have like a debt of 3 million euros or something like this. So this is completely a clean company. So both parent companies, both Airbus and Safran, was avoiding to put any kind of a debt inside of this. That's why we can issue bonds if we need funding. Or if we are operating as a venture capital firm, then we can do more investment now, and 5 years later we can sell or package at the stock market for the fair value, what we achieved here, and that's why we can also fund through equity. But in this case, we have to extend the amount of equity, so it will be also fun. Also, to calculate the weighted average cost of capital, we need ways to define the expected rate of return from equity. This is when we are using capital asset pricing model approximations. In the case of that, it's really simple, because this thing is rated as a BB company. We will check it on Thomson Reuters database. So we will use market data, obviously. And we will check that what is the average interest rates right now for companies at the same rating. So, and also we will check that what happens if interest rates are increasing, decreasing. So we will do a whole sensitivity analysis on this thing. But it will be your discount rate. To discount the free cash flow, we will have the discounted cash flow. In case of assets, tangibles and intangible assets, this is the problem here, because we can say that book value, if we don't have any idea, then we can say that, okay, we have to use the book value. But if you have to sell a launch complex as a salvage value, obviously there are not many people who would like to use this launch complex. Mostly it has scrap metal value, unfortunately, for the remaining part of the. So in case of assets, I had this issue many years ago when I had to define a private company's value, and this was a logistics center. And this logistics center was building a roundabout at the main road of 5. It's next to the highway, close to Szeged. But they had a roundabout in their books. But they spent 1 million, around 1 million forints on this roundabout, or maybe just 80 million, whatever. But in this case, this asset is, nobody would like to buy a roundabout. Yeah, the municipality maybe buys, but Road 5 is a state road, so not even a municipal road. So Calvaria, this one is municipal road, but for example, the big circular road around with the city names in it, that one is a state road operated by Magyar Közút, so it's not, that's why the conditions can be different here and there. So, so in this case, what is the fair value of a roundabout? If we can assume that the state will buy, or the municipality will buy this roundabout from them, then we can say that, okay, we can use book value. But if we are conservative, we can say that, no, we should drop this thing out. Intangibles are also special, because if the intangible is the trademark, and in many cases the trademark is there, so it's not license ownership, not or some kind of a know-how that we can sell on the market, or IP, so intellectual property, but just trademark, who cares about trademark? So that one is useless. In case of Arianespace, they are really good in metal 3D printing. So ASA altogether were really ahead of the industry, and they were developing many parts and procedures. How can you print metal? And even they have a 0G metal printer, so they can print metal components in space. I was able to push it when I was manufacturing things. So yeah, it's so you can throw it around and so on. It still prints reliably, and it's really interesting. So some of the intangible assets can be useful. The problem is that if we have only the books, we don't see anything like this. So this is non-transparent. So in the case of case study, we don't care about this. We are saying that, okay, we can sell everything at book value. But if you are doing it for a real company, you have to be really, really careful, because companies and managements will always put everything into their assets. And everything will be absolutely overvalued. So if your job is to determine the fair value of a company, and you are an investor, or you are preparing this company for acquisition or merger or something like this, so you are an independent third party, you have to be really careful, because they will try to show you shiny things, even if it's not even in their possession, or it's completely rubbish at the end of the day. So you should check everything. Once we had this, oh, it was really sad. It was also some kind of a logistical company, but they lost their customers completely within a year. So before of that, it was a cash cow. It was generating more than 50 million forints in a year. And each year, it doesn't have any kind of a debt. But suddenly, competition arrived, and it was just practically robbing them from clients. So, and they were burning up more than 100 million Hungarian forints of cash reserves. So when I arrived, or when we arrived, it was just 30 something what remained. And we were asking that, nice assets what you have. Yes, we have everything. Okay, how about the plot of land? Oh, it's we are just renting it. Okay, but you have these assets in the balance sheet. Yes, because we have this building on the top of this land, but it was just like a small office building, 2 toilets, a kitchen, 1 office for the director, 1 office for the rest of the crew. There was a warehouse, but it was also owned and operated by another company. So at the end of the day, we were able to realize that all their asset was the fencing, some lighting poles, and obviously some electricity, wiring, and the toilets. So in this case, we had to say that the owner wanted to sell this company, and we had to say that, no, guys, please close it down. the company doesn't have any kind of an intrinsic value. So the fair value is 0, and if you are closing it now, then at least you can grab the cash reserve, and there is nothing else. So at the end of the day, it was sad because it was closed down before Christmas, and but after that it was even they sold the land. So it was purchased by the neighbor, and they were able to hire some of the people from there. So sometimes this is sad, but you have to be really careful what is here. Or my favorite thing was during the Enron scandal. Enron was, I don't know, you are too young to remember, because Enron scandal happened in 2001 when I was in high school and you were not in high school. So Enron was a US company who, it was in the energy business. So they had power plants, gas pipelines, and so on. And that was a time when the energy market, gas market, electricity, and so on, was liberalized in the US. And now we know that the company was never profitable. So since 1994 until 2001, they were not profitable, but it was listed on the stock market. So the management had high incentives to make it look like it's profitable. So they falsified completely the statements. Also, the accounting company was under them. Their audit company was also under them. That was the reason that nowadays it's forbidden to have the same company for accounting and audit. And also we cannot see, right now we can see that there is the big 4. At that time it was big 5. So under them after that. It was imploding within a night when the scandal happened. That they were falsifying books. So they had assets which were not in their possession. So they were saying that, oh, we rented out some oil tankers. So now these oil tankers are in our books. We are accounting depreciation on them. And you can do it if you are using long-term financial lease contracts. In this case, it can be in your but that was not the case. So they were just short-term renting. And also they were selling assets, buying back assets to create artificial revenues. So at the end of the day, that was a huge scandal. In Europe, the same thing happened just with Parmalat. It was an Italian company in the food business. For example, in Hungary, they were selling milk and cheese and things like this. And also WorldCom, it was in the IT sector, but it survived later on. So there were many scandals just in 2000, 2001 because of misreporting and falsifying completely the records. So that was the reason why nowadays we have Sarbanes-Oxley Act that so before of that, management was able to say that, oh, we had no idea that the books are falsified. Now, if your company is listed on any US stock markets, and as a manager you are signing the annual report, then if the report was falsified, then you can go to prison for 20 years. On paper, in practice, I was never able to see that anyone was sent to prison. So if you have good lawyers, maybe you can avoid this. But that's the reason that if a company is publicly listed, then they are spending a lot of money on lawyers. So when Hungarian Telecom is a subsidiary of Deutsche Telekom, just is listed on the market, they had some dubious. So they purchased a company in Montenegro, an IT company or telecom company, Montenegro in the Balkan Peninsula, and obviously some corruption happened. New government came, obviously they were angry for the previous government, so they were saying that this privatization happened because of corruption. And after that, Hungarian Telecom had to hire US lawyers, fly them from New York on plane, back and forth for 5 or 6 years. This is an enormous expenditure. So the whole management, the whole Hungarian management was fired because of this. It was sad because they were building up the whole telecom sector here, so mobile phones, fiber optics internet, so all the modern IT and telecom thing was built up by these managers, but after that it was ruining their name completely. So at the end of the day, nobody was prisoned or they were able to settle with the local government. I don't know what happened, but nowadays we cannot hear anything about this. So that's why listing on the US market, it's not scary or not risky, but it can be really, really expensive. Something like this, or like this, the thoughts can come. Okay, so this is what we have to do next time.